The gradient of the tangent to the curve y squared is equals to 4x plus y at the point 0, 1 is a 5 on 2, b 4, c minus 4, d minus 2. The gradient of a tangent to a curve is denoted mt, which is always given by the formula dy dx. So to get the gradient of this curve, I need to differentiate this equation with respect to x. That is, I need to differentiate implicitly. You also have to know that if y is equals to x to the n, then dy dx is equals to nx to the n minus 1. So here I'm going to have 2y dy dx is equals to 4 plus 1 dy dx. Here I have 2y because y to the 2 can be differentiated using the formula as 2y to the 2 minus 1, where my 2 here is n, which is giving me 2y to the 1, which is the same like 2y. Since this function is differentiated with respect to x, so anytime that I differentiate y, I have to write dy dx beside. That is the method. Like here, I differentiated y, I had 1. That is y to the 1 minus 1 times 1 is the same like y to the 0. That's 1y to the 0. Y to the 0 is 1. So that's why I'm having 1 here. So I write dy dx beside. So the same here. X to the 1 minus 1 times 1 is equals to x to the 0, which is the same like 1. So here I had 4 times 1, which is 4. So from here, I need to make dy dx the subject of the formula. This means 2y dy dx minus 1 dy dx. Since when dy dx crosses the equal sign, it becomes negative, which is equals to 4. That means we factorize dy dx. We're going to have dy dx into 2y minus 1 is equals to 4. Now I divide both sides by 2y minus 1, 2y minus 1. 2y minus 1 cancels here. I'm going to be left with dy dx, which is equals to 4 over 2y minus 1. So at the point 0, 1, the gradient will be dy dx is equals to 4 over 2 into 1 minus 1. So you know the value of y in this point is 1. So in the place of y, I substituted 1. 4 over 2 times 1 is 2. 2 minus 1 is 1. That's 4 over 1, which is the same like 4. The right answer is this, which is B.